Now let's see effects of catalysts. Now a catalyst is a substance that speeds up a reaction, but itself is not changed chemically at the end of the reaction. So if you start with let's say vanadium 5 oxide, at the end of the reaction you will still have vanadium 5 oxide. It does not change, and every single reaction will have a different catalyst. So for example, you have vanadium 5 oxide, which is used as a catalyst in the contact process to make sulfuric acid. You have finely divided iron particles, which is used in the Haber process to make ammonia. You have manganese 4 oxide, which is used as a catalyst for the decomposition of hydrogen peroxide to form oxygen gas. Now, if you look at all these catalysts, you see manganese, iron, vanadium. These are all transition metal. So, transition metals, they form good catalysts, or they form compounds which are good catalysts. Now, catalysts will make you get the product faster, so it saves time. However, it will not give you more product. It does not affect the yield. The yield can only be affected when there is changes in the equilibrium. So remember, where you have the reversible arrow, you have the equilibrium that shifts from one point to the other. So if it shifts to the right, you'll have more product, so it increases yield. If it shifts to the left, you'll have less product, so yield decreases. So catalyst will only affect the rate. So it will make you get the same amount of product but faster. The products usually are formed at lower temperatures. So if you would require to heat at, let's say, 2000 degrees Celsius, a catalyst would allow you to get the product at lower temperature. So lower temperature means less energy. Catalysts can be used over and over again, and even if they are expensive, a small amount of it is enough to catalyze reactions. Now, enzymes. Now, these are biological catalysts, and these are made in living organisms. They are proteins. They are made in living organisms, and they allow reactions to take place faster at body temperatures. And enzymes work at limited range of temperature and pH. So, for example, you have some enzymes that would be able to act only in the stomach at pH of around 1 to 2. For example, pepsin.
To increase the rate of decomposition of hydrogen peroxide, carry out the following experiment. Measure 25 milliliter of hydrogen peroxide by using a graduated cylinder. Place the compound into a clean conical flask. Add the same volume of hydrogen peroxide into another conical flask. Add the black powder of manganese dioxide gradually to the first flask only. Compare between the reaction in the first flask and the reaction in the second one, related to the rate of reaction. Oxygen gas evolves with an effervescence in the first flask, showing that the rate of reaction in it is faster than the rate of reaction in the second one, due to the effect of manganese dioxide as a catalyst. Summary: manganese dioxide is used as a catalyst to increase the rate of decomposition reaction of hydrogen peroxide into water and oxygen that appears in the form of effervescence.